Hello friends, welcome to my channel IT Training World. I am Deepak and I have 15 plus years of experience and I am making multiple training videos on multiple topics that can help with your career. So don't forget to hit on subscribe button and don't forget to like, share and provide your feedback in the comment section. So friends, today is a topic that I am covering is SQL Always On. So Always On feature was uh, taken by Microsoft in SQL 2012, and since then it is one of the popular feature, and it is getting used in 2014, 2016, 2019. So this is continuously upgrading itself because of its popularity. So SQL Always On is a high availability and a disaster recovery solution. So let's get started with the introduction. The Always On Availability Group feature is a high availability and disaster recovery solution that provide an enterprise level alternative to a database mirroring. As you know that previously we had a database mirroring in SQL 2008 and 2005 we have database mirroring. We what we used to do is we create a database mirroring for a database and uh, get sometimes a DR solution, sometimes a, disaster recovery solution out of it. So there was one more feature in SQL 2008 and 2005, which was used as a DR, that was clustering. So in clustering, we were using is as a high availability. If one node fails, then it will take over to the other node and so on. So the only issue over there was the storage. The storage was a single point of failure over there. That's why we started using mirroring, because mirroring used the two type of storage. The storage, it's not a shared drive, so there are different set of storage which gets replicated. So what Microsoft thought was to combine all the features of clustering as well as mirroring, and they come up with an always on availability group. So, as I said, it was introduced in 2012, always on availability group, and it maximizes the availability of set of users for an enterprise. An availability group supports a failover environment for a discrete set of user database known as availability database that fail over together. In case of mirroring, it was like we when we fail over a mirroring of a particular a database. So what it used to do is we have to fail over all the database that are related to a particular application one by one. But in this case, what we will be doing is we will be creating a set of databases, and all those set of databases would be failing over to the other node together, right? So in that those group of databases are called availability databases. So an availability group supports a set of read write primary database 1 to 8, probably 9 set of corresponding secondary database. Secondary database can be made available for read access, reporting, and some of the backup operation. So over here that we have one database and we can create uh, 8 more read replicas for those database, and we can put one read replica in, let's suppose, one our primary data center. We can keep another read replica into a secondary data center, thereby providing us an high availability. We can also uh, do is that we can create a, a replica in Azure as well. There is a feature that we got in 2016, that we can create one replica of our database in SQL Azure. So when AV availability group database failover, when does it failover? So this is a bit technical before we start. So how does it provide the when the, is it doing an automatic failover or is it a manual failover? If we configure it to do an automatic failover, in that case, an availability group failover at the level of availability replica. Failovers are not caused by database issues such as database becoming suspect due to loss of data files, deletion of a data files, or a corruption of transaction log. So what does that mean? That means that if something happens to your database internally, this the database failover will not occur. Only the database failover, automatic failover, only will occur when there is network issues. If there is any network issues and application is not able to connect to a listener, or listener is not able to reach a database, listener always checks whether a database is online or not, whether the server that is hosting that database is available or not. So listener continuously checks it. So in that case, what happens, like if listener finds that uh, on the server on which a database is hosted that is offline, in that case it it will redirect it to a secondary database, thereby providing a seamless failover, and application will not will be down for a couple of seconds, not more than that. Benefits. Let's come to our benefits. So each availability group supports one replica and up to 8 secondary replica that we discussed before as well. Next is SQL Server 2019 increases the maximum number of synchronous replicas to 5 and up to 3 in case of 2017. So when it was introduced at that time, the synchronous replica that it could create was one or two in case of 2012. But as we get on to 2016, we can create three synchronous replica, and we can create five synchronous replica in case of 2019. However, there we can, if we are creating non-synchronous replica, then we can go up to 8 or 9 uh, replicas. So to synchronous is like if a transaction is made on a primary database, it should first commit on secondary and then commit on uh, a primary database. So what it does is, in case of synchronous replication, what it does is provide a data security, that data is not lost in case of synchronous replication. However, in case of asynchronous replication, it provides performance wise it is faster. However, it does not wait for acknowledgement from a secondary server, and it writes everything to a primary, and it does not wait for secondary to commit. So even if the bandwidth between the primary and secondary, we do not have that much bandwidth, and there is a lag we are facing. So if we create a synchronous application, it would have performance impact. Or else, if we are not creating we should go for asynchronous, so that it should not impact our database performance. So this we already discussed, asynchronous commit mode and synchronous commit mode. Asynchronous commit mode is that when we write a transaction, it will first commit to a secondary, uh, and in case of synchronous mode, it will commit to a secondary and then commit to a primary, whereas in asynchronous mode, it will commit to a primary and will not wait for commit to a secondary. Secondary can be committed in any time, so it is asynchronous commit mode. So this is basically you can see a diagram in which I have created a primary replica, secondary replica of my availability group. In this, I have one primary and four secondary replicas. So in this case, when we are creating always on, all these five should be a part of Windows Server failover clustering group. Your You should first create a Windows Server failover clustering group for all these five servers, and then only you will install the all SQL server standalone mode in all these servers, and then you will go ahead with configuring of availability group and its replicas. So let's talk about AG group listener. So this is one of the important thing that is a part of Always On. An availability group listener is a server name to which a client can connect in order to access a database in a primary or secondary replica. So what does that mean? That means that when we are connecting from application, when we are connecting through a connection string to that particular application, so what we have to do is that we have to give the listener name over there, and uh, which will connect to our database. So whether our database is online or active on a primary node or a secondary node, it will connect automatically to the availability group. So availability group listener direct incoming connections to a primary replica, or to a read-only secondary replica. And listener provide a fast application failover after an availability group failover. So in some cases, to to avoid the load on the server, what we can do is we can connect our backups. We can take a backup from a secondary node, right? And we can use a secondary node as a reporting application, as a read-only purpose. Like if we have some reports running, we can run the reports from a secondary node rather than going for a primary node. So in that way, we can use the secondary replica as well, and remove the load on a primary replica. So this AG group listener, it will automatically redirect. If you in the connection tree, if your intent is read only, it will automatically redirect you to a secondary replica, right? And if you in the settings, if you say that take a backup from secondary node, so you do not have to specify a secondary node over there. You just have to specify the AG group listener name, and the backup will automatically be taken to from a secondary node. So that's it for today. So uh, so we will be doing a practical session in my upcoming videos about how to configure always on, how to uh, how to build always on availability group, availability listeners, what are the steps, step by step guide. I'll make it in the next videos. So don't forget to hit the subscribe button, uh, and do subscribe to it, and provide your comments on it. Thank you.